Okay, this is going to still be 2.3 notes, okay, but this is part 2. Just makes it a little bit easier for me to upload. So I'm going to give you another example, okay? We're going to divide x to the 4th. I'm sorry, never mind, 5x cubed. Let's do that, a different one. 5x cubed plus 8x squared minus x plus 6 by x plus 2. Okay, still using synthetic division, just one more practice problem. The upside down bar. If you'll notice, we descend from the third power to a cube to a first to a constant, so there is no need for a filler on this one. So 5, 8, -1, 6, and the divisor should be by the 0, so we divide by -2. All right, again, drop the 5 down and multiply. That's -10. Combine your terms. 8 minus 10 is -2. Then you multiply. -2 times -2 is 4. And then you combine your terms. -1 plus 4 is 3. Now we combine our term. We multiply. -2 times 3 is -6. That one comes out with no remainder because you have a 0 down here. And when that ends up a 0, that just means that it went in even and that you have no remainder. So look at your highest power when you get ready to write your answer. We started off, our dividend was a cubed, so we're going to start with 1 power less. So that's 5x squared minus 2x plus 3. And that is my answer. And that's all you have to do, okay? No remainder on that one. That's nice when they come out even. So that's synthetic division. Now then, like I was telling you a while ago, the next concept that we're going to do is called the remainder theorem. The remainder theorem is really a neat thing that enables you to evaluate a big, long polynomial kind of quickly. Okay, so we're going to take this polynomial right here, 3x cubed plus 8x squared plus 5x minus 7. And I want to tell you to evaluate this at x equals -2. Okay, so notice that's already a 0. You're not going to have to change anything. So what I mean is that you take the -2 and you plug it in for x everywhere. Well, I'm going to show you a really quick way to do this. This is the remainder theorem. We're going to do synthetic division. Put your values in, 3, 8, 5, -7. I'm going to use my divisor as a -2 because it's not set as a factor, it's already set as a 0, so I use it as it is. Now, the remainder theorem says that if you do synthetic division, that your last value that you get right down here is the actual value that you would get if you plugged -2 into that equation. Okay? So I'm going to drop the 3 down, and I multiply, combine, then I multiply, combine, then I multiply, and when I get this last term right here, -7 minus 2, that's -9. Okay? That value right there, the -9, is the actual value you would get if you took this -2 and you plugged it in. 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7, you would actually get -9. And if you don't believe me, type it in your calculator and check it out. So that's called the remainder theorem. It's really kind of cool, something that you need to be able to do. The remainder theorem. Okay, let me write that down for you. Okay, so it's very important that you understand when it says evaluate using the remainder theorem, you just take that value that x is equal to, do synthetic division, and the last value that you get is the actual value of that entire polynomial evaluated at that number. Very easy. Okay, now then we're going to do one more thing. I'm going to get you to show me, okay, that these two factors, x minus 2 and x plus 3 are factors of this big polynomial right here, 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. In other words, if I gave you this gigantic polynomial and I said factor that, you would get 2 of these as factors, okay? Now what I'm going to do is I'm going to show you that those are factors, and I'm going to use synthetic division to do that. So I'm going to take the original polynomial and I'm going to write down those coefficients into my upside down division bar. Okay? And I'm going to take the first factor, which was x minus 2, and I'm going to use the 0, and I'm going to show you that it's a factor, because remember, if it's a factor, that means it goes into it evenly without any remainder. So we should get a 0 right down here. That should go out to a 0 if it's a factor. So watch this. Bring the 2 down. That's 4. Combine your terms. That's 11. Multiply. That's 22. 22 minus 4 is 18. Then multiply. 18 times 2 is 36. 36 and negative 27 gives you 9. And then you multiply 2 times 9 and you get 18. And look what happens. That comes out as a 0. So that shows that x minus 2 is definitely a factor, because that was a 0 right there. So check. You showed that one. Now to show that the other one is a factor, you're going to do synthetic division again, but you're going to use this right here, because what you did is you just reduced that, okay? So you're going to use that as your entry. Okay? And the other one, which was x plus 3. Okay? Hopefully you're already thinking, oh, we need to use negative 3 as our divisor. And we're going to do this, bring the 2 down, and we should get a 0 at the very end. So negative 6, and that's 5, negative 15, that's 3, and negative 3 times 3 is negative 9. So look, there's your 0 right there. Now look what you have. 2x squared plus 5x plus 3. See, I started with 2 powers lower because my original had the highest power of 4. So this one right here reduced it to a cubed. This one right here reduces it to a squared. Now watch what you can do with that. Okay, let's take our 2x squared plus 5x plus 3, and we can factor that because we know how to factor. Okay, we're going to use bottoms up. X squared plus 5x plus 6. Not forgetting about our 2. We're doing bottoms up. You know how to do it. X plus 2x plus 3, right? And then we take our 2 and put it underneath. From right here, it's going underneath. So we reduce. That's x plus 1 and 2x plus 3. Now what you have done is you've used synthetic division to help you factor this entire polynomial that was of 4th degree. Okay, the first factor I gave you was x minus 2. The second factor that was given in the problem was x plus 3. And then you came up with these factors to finish it out after you did the synthetic division of x plus 1 and 2x plus 3. Now what you did is you just factored that entire polynomial because you used synthetic division. Now I'll have to give you a 0 or 2 to get you to that point, but isn't that neat? That's really cool. You can do that. So all of your zeros, if you had to find the zeros, would be 2, negative 3, negative 1, and negative 3/2. And that goes back to our lesson yesterday of where these would cross the x-axis, how many turns it would have, what it would do on the right, what it would do on the left, whether it would cross the axis or whether it would just touch the axis. Remember, it just touches when it's even, it crosses when it's odd. So that's a pretty cool way to do that. Synthetic division, given the factors, and you can take it all the way down to the complete factorization. Okay, that's all of the notes for section 2.3. So what you need to do is go to your packet and do the assigned problems for 2.3. You guys have a great day.